Hello, students. Okay, so today we are going to learn about something called L'Hopital's rule. And this is section 4.4. And what it is a method to evaluate limits of expressions that are in indeterminate form. So we've actually done indeterminate forms before, which were 0 over 0 and infinity over infinity. And we had special strategies for those. Now, L'Hopital's rule can work for those indeterminate forms, and they can work for other indeterminate forms as well. And they work for ones that we cannot use the strategies that we talked about before. For instance, when we got infinity over infinity, we would divide by the highest degree in the denominator, which means we generally had a polynomial of some kind. But the problems that you're going to see today are going to be the same indeterminate forms, but the strategies we learned won't work. So this can be used for all indeterminate forms. So here are all the indeterminate forms, which you're eventually going to have to put on a flashcard. So the first one is indeterminate quotients, which is 0 over 0 and infinity over infinity, which we've done before. The next one, which we've also done before, is infinity minus infinity, which is an indeterminate difference. Indeterminate product, 0 times infinity, or even 0 times negative infinity. And the last one is indeterminate powers, which actually we just be aware that they exist, but we're not going to do those, okay? We only need to know these ones. All right. So at any time during this video, feel free to pause and then rewind if you need to. So here is L'Hopital's rule, okay? If you have an indeterminate form, L'Hopital's rule says this. If you have a limit and it's indeterminate, then what you can do is you can take that limit and you can take the derivative of the numerator divided by the derivative of the denominator. Okay, so what that means though is then you have to have a fraction. So the ones that we learned about before, 0 over 0, infinity over infinity, generally had fractions. Infinity minus infinity means that we have an expression that is not in fraction form, but we're going to learn how we can turn it into fraction form. Same with 0 times infinity. That is not in fraction form, but we will learn how to turn it into a fraction form. In other words, a rational expression, so that we can apply L'Hopital's rule right here. Again, this can only be used, L'Hopital's rule can only be used if you have it in fraction form as a rational expression. All right, so the first one that we're going to do, our first example, is this guy. All right, so limit as x goes to 1 of our function natural log x divided by x minus 1. So let's see what happens when we put in 1. If we put in 1, natural log of 1 is 0. And if we put 1 in there, we have 0. So is this an indeterminate form? Let me see. Yes, it is. So if it is, then I get to use L'Hopital's rule. So since it's already a fraction, I'm going to apply L'Hopital's rule. And I just write this off to the side so I remember what step I did it in. And now I will say limit as x goes to 1. And I'm going to take the derivative of the numerator. So what's the derivative of natural log? It's 1 over x divided by the derivative of the denominator. So what's the derivative of that? That's 1. Yeah. Okay. Now, before I continue, I like to simplify my expressions first. So when I simplify the whole expression, that's just going to be 1 over x, which is so easy. And so now, after I simplify, then I will substitute. So I will substitute it in, and I go, if I put that in, that's going to be 1 over 1. So therefore, it's 1. Yay! Highlight. Like so. Okay? So the next problem is this expression. I'm going to put infinity in, so I'm going to get e to the infinity, which is infinity. And I have infinity squared, which is infinity. So I have an indeterminate form. If I have an indeterminate form, then I can use L'Hopital's rule. And in order to do that, my expression has to already be in a fraction. So, which it is. So now I'm going to go ahead and I'm going to apply L'Hopital's rule in the next step, which is limit as x goes to infinity. And the derivative of my numerator is e to the x. And the derivative of my denominator is 2x. So now I'm going to see what I get. If I put in, I can't simplify this. So I'm going to put in infinity. If I put in infinity, I'm going to get infinity. And if I put in infinity in the denominator, I'm going to get infinity as well. So again, I have infinity over infinity, which is an indeterminate form. So I will have to apply this again. So applying it to my second step. That's infinity. And the derivative of e to the x is e to the x divided by the derivative of 2x is 2. So now let's substitute our infinity in. And so when I put it in, I will have e to the infinity divided by 2, which is infinity divided by 2, which is infinity. Yeah. Highlight. So easy. All right. So now let's try this guy. This one, if I put in 0 into my x, I'm going to have 0. And if I put in 0 into here, now you cannot take natural log of 0. But we are approaching 0 from the right, which means that we're not necessarily looking at 0. I am looking at what's happening as I approach 0. And this is my natural log graph. So as I approach 0 from the right-hand side, where is my expression going to? It is going to negative infinity, which is an indeterminate form. It's an indeterminate product. So therefore, we will apply L'Hopital's rule. But what is the problem here? The problem is this is not in fraction form. So that is what we are going to do next. So I'm going to do this on my next video.